I don't understand. Why is it a pain? I was like tamper. Those two are like silver buttons. Mr. Townsend.
Yeah.
I don't get the news. Why is it a 10?
What's sine divided by cosine?
X over Y.
Now, what other trig function is the same as sine over cosine?
So.
It's about to be on your quiz, so you can try to study. Sine over cosine is always tangent. Tangent, okay?
Oh, yeah. Okay. That makes sense.
And then a tangent sine over cosine. The cosines get cancel, and you'd be left with sin sink. Sink. That's it.
Okay, thank you.
Plus, I'm giving you an indirect hint to today's quiz by putting this up there, so if you're paying attention, you get a little bit of a boost.
Yeah, I should have been able to do that myself. Let's see. Lucas. Alright, I need you guys to clear your desk off for our quiz.
You guys don't have to put your phones away, but just make sure you don't have them out on your desk at least. I don't want you to accidentally grab it. This is a report. Just straight up, did you memorize what you were supposed to memorize? questions are matching, so I'm going to fill in the blank. All of it is exactly how I warned you about from our notes. So I'll leave you to take that opportunity.
Yes, just take one when you need it, please. Okay, and now that everybody has it, please put your name on it and please number it as number 14. And it does total to 20 points. So I would double check as much as you can before you turn it in personally. And as always, as you finish, the basket up here by my desk is where I need it. Okay, just a few more minutes if you're still working. Okay, and if you're still working, you need to finish up and come get it turned in. For the rest of us, let's move on. So hopefully you felt like that was a few easy points, since all you had to do was memorize it. You didn't have to know why it was true or prove it was true or understand why it was true or any of that. But the better you understand those things, the easier this second half of section 4.3 is going to go. So there was 2 handouts you guys picked up today, 15 and 16. I already numbered those for you. So in my opinion, I think this may be one of the harder things we do all year long, because you have to A, have these basic identities memorized, and B, every question is kind of different. I can't just say always do this for step 1, then always do this for step 2, and then always do this for step 3, and then you get your answer. It takes a little bit of creativity. So that's why we have 2 handouts. The number 15, these questions are a little bit easier to help you kind of get your footing of what we're doing and how to go about it. And then the other handout, those questions vary in difficulty. Some of them aren't too bad, and then some of them are kind of messy. But okay, so to verify or to prove trig identities, what we're basically doing is we're showing that this is true. So there's tons and tons and tons of true relationships in trig. In fact, everything on here is true. So this is not a true or false question. We don't want to know if you think it's true or not. We're telling you it's true. We're asking you to show us or to verify for us that this is true. So what you have to do is you have to think of ways, either with a little bit of algebra, like fractions, factoring, stuff like that, mixed in with a little bit of trig identities, like knowing your reciprocal identities, knowing the 3 Pythagorean identities. We've got to make these substitutions until we can make one side look like the other side. So the most common careless mistake here, and you need to make sure you hear this is not an equation to solve. If you are ever adding, subtracting, multiplying, or dividing both sides of the equation, your question's wrong right away. This is not an equation we're trying to balance. So, as a good rule of thumb, if you just leave one side alone, usually the more simple side, and then just try to play with the more complicated side. So we have to think of a way, and there's not just one way to do this either, by the way. So, of course, in mathematics, we're aiming for the most efficient way, but we got to think of a way to make this look different. So, what is a different way to say tangent? Okay, so one possibility is sine over cosine. What's a different way to say cotangent? Okay, that's also true. And again, this is where I think this can be one of the hardest things we do. Both of those things you said were true, it just wasn't helpful because nothing cancels out here. Why don't, instead of maybe changing tangent, maybe we leave it alone? Because now I can see times tangent divide by tangent is going to cancel, and I have shown that the left side is equal to the right side. Vice versa, you could have changed tangent into 1 over cotangent, multiplied your fractions, You could have changed tangent and sine over cosine and cotangent and the cosine over sine. I can't begin to show you all the ways to solve all of these, but we made a trig substitution. We changed this into this, and then that was allow us to show that the left side is in fact equal to 1. Okay, so what would you maybe want to change in question 2? Okay, so sometimes you're not going to know if it's going to help, but you've got to start somewhere. So maybe change secant into 1 over cosine. And then times cosine divided by cosine cancels. And we have shown that the left side is in fact always the same as the right side. So this is another identity. It's just not one that we use enough to bother to memorize. We can figure it out, or we can prove that it's true in the moment, as long as we have the basics memorized. All right, so I want you to think about 3 for just about 10 seconds before we talk about it together. I want you to start to think about what jumps out at you. All right, what would you try to change in question 3? Okay, change tangent to what? Sine over cosine, thank you. Sorry, I can't hear that great with the fan. Our air conditioning was broke last week, and then they finally fixed it, but then it broke again, so. Okay, so again, what can be frustrating is you don't know if this is going to help. Just like on question 1, people threw out a couple things that were true and it didn't help. But you got to put pencil to paper, you got to write it down, and then you got to see if it helps. Times cosine divided by cosine cancels. I have shown that the left side is always equal to the right side. Notice how I'm leaving one side alone. If you add, subtract, multiply, or divide to both sides like you're solving an equation, it's no longer true. That doesn't always hold up, so that's why we can't do that with proofs. Okay, along the same lines, what could we do with question 4? 3 and 4 look pretty similar to me. Okay, cotangent could be 1 over tangent, which I just don't think is going to be helpful here. What's the other thing that cotangent is equal to?
Cosine.
Cosine over sine. And again, this is why at least from our perspective, we feel like we're giving you those quiz points by memorizing these. Because if you don't know cotangent's cosine over sine, then you really don't have many options to do that question. But if you do, the fraction work behind it is pretty simple. Okay, so now we're going to slowly start to step away from the most basic of questions and start to build up to ones that are a little more complicated. So, the last fail-safe on all of these questions, just kind of a last resort, don't make it your first resort or you're going to make some of the questions way harder, is always try to, well, if nothing else works, try to change everything in terms of sines and cosines. So like call this what it's equal to in terms of sines and cosines. Maybe call this what he is in terms of sines of cosines. And this guy is already in terms of sine. So change everything into sines and cosines and then see where you land. So notice times cosine divided by cosine cancels, times sine divided by sine cancels. Looks like the left side all simplifies to be 1, which is what I was trying to prove. Now I say do that as a last resort because there will be some of you that try to do that on every single question, and in theory it works, but you're going to make some questions way harder than they need to be. So change everything in the sines and cosines needs to be at the top of our list. Okay, so the first 5 we saw a lot of like fraction work, but as I mentioned, it could be algebra work as well. So when I look at these two things, to me, it looks like something you would try to FOIL in Algebra 2. So I don't know 100% sure that I should FOIL these, but it's my best guess. So let's FOIL and see what we get. Now technically you can work with the right side instead of the left side if you'd rather. Overall, you should be working with the side that looks more complicated. The more complicated side is usually the side you want to mess with. So to me, looking at that question, it looks like it was begging to be FOILed, so I did that. And then it looks like we've got some like terms that are going to cancel out right away. And then to finish, we still need to show that 1 minus sine squared is the same thing as cosine squared. Now, this is actually one of the easier things to do, but only after you're really comfortable with these. The first Pythagorean identity, probably the most important one, says that sine squared of some angle plus cosine squared of the same angle always has to be 1. This is considered a basic identity, so you never have to prove this. You don't have to show anybody or convince me that this is true. You're welcome to use this as a tool to help us here. So don't add the sine squared over, because we're not solving an equation. We're leaving one side alone. I'm leaving this side cosine squared. I'm messing with the left side. But I can say, well, wait, I know this to be true. Let me solve it for 1 minus sine squared. Subtract the sine squared over. Now, this isn't my proof, so I can do that. This is the thing I have memorized. I can't add or subtract things to my proof. And it looks like in place of 1 minus sine squared, I can replace that with cosine squared. And then you're finished. So again, you don't have to prove why 1 minus sine squared is cosine squared. That's you having the basics identities memorized and applying them correctly. Now, if you don't have those basic identities memorized, you probably want to leave those notes out for you to refer to. All right, so in question 6, it looks like foiling helped out. Question 7 kind of looks the same, so I'm going to guess that maybe we should try foiling. Again, you never 100% know until you try it. So try to foil it, see what else happens. And as long as we're not breaking any algebra rules, any making up our own trig identities that are not really true, there's a multitude of ways you could probably finish this. But I think if you consider foiling, it's pretty obvious that these terms add to 0, so you might as well cancel them out. Now what about this? Does this look familiar? So in fact, what I recommend to students is you're starting to see that you're going to need to know those 3 Pythagorean identities. So typically what I do is I write down the first one, divide them all by sine squared to find the second one, divide them all by cosine squared to find the third one. And I just do that once at the top of my paper so I have a visual. Because I can visualize up here, if I subtract this over, 1 minus cosine squared is equal to sine squared. It's not on me to prove why that's true, because that's a basic identity that we memorize. But if you don't have it memorized, then you certainly aren't going to recognize that you can just switch that to that. Again, I'm just looking at this first Pythagorean identity, imagining subtracting the cosine squared over and saying 1 minus cosine squared would be equal to sine squared. That's why I can make that substitution from that to that. Okay, so looking at number 8, what do you think the first step's going to be? Okay, so let's FOIL. Secant times secant, secant squared. Secant times negative tangent would be negative secant tangent. Tangent times secant would be secant tangent. And tangent times negative tangent would be negative tangent squared. Somehow all of this mess is supposed to come out to be 1. So again, it's going to be that this is true but it's not one we memorize. But if we have our basics memorized and we can do algebra stuff like foiling and multiplying fractions, then we can show that left side is the same thing as 1. Okay, what happens after we FOIL? Okay, you could say secant squared minus tangent squared. Now, if you have this written at the top of your page, it's a lot easier to see what that's going to be equal to. Secant squared minus tangent squared would be equal to 1. So in place of these two, we could put 1. And then what about these two? They just cancel, right? They're the same thing, but one's positive and one's negative. So I think most people probably would have done that on step 2 and then this in step 3, but it doesn't matter. I'm not breaking any math rules to get that left side to show that it's always equal to 1. Okay, so slowly bumping up the difficulty again. So we see that we're plugging in trig identities, reciprocal identities, quotient identities, Pythagorean identities. We've used some foiling, we've used some fraction work. Pretty much any algebra is fair game. Okay. So in the top left, number 9, this one takes a little more thought into what to do because it doesn't look like it needs to be foiled. I guess some of our basic identities have sine squared in them and some of them have cosine squared in them, so maybe I could rewrite them. But to me, when I look at this, my big clue, and it's a little easier for me to see because I've done a lot of these, but this side has some sine squared stuff and the right side only has sine squared stuff. So I really want to get rid of this cosine stuff and better yet change it into sine stuff. Well, one of our identities no, that's if it's plus. Sine squared of an angle plus cosine squared of an angle equals 1, but subtracting could be something else. If I'm looking at this, I could think, well, sine squared is equal to 1 minus cosine squared. Oh wait, I don't want to do that though, because I don't want to change all these to cosines. I want to change them all to sines. So cosine squared is equal to 1 minus sine squared. So because this is true, I can make that substitution right here. So I'm just carrying down the sine squared, but instead of saying cosine squared, I'm going to say 1 minus sine squared. And again, my big hint to even know to try to do that is just looking at this other side. It wanted another sine squared, and it didn't have anything to do with cosine squared, so I had to figure out some way to get rid of the cosine squared. Well, if you think to do that, then you're in pretty good shape, because then you could just distribute the negative, combine your like terms. A sine squared and a sine squared is going to give you 2 sine squareds, which is what you wanted. You've got a minus 1, which is what you want. And now the left side equals the right side. You really should state in the last step that the left and the right are exactly the same thing, but you don't have to copy this down every single step. If you leave this blank, it's implied that this just kind of carries down. So thinking about what you have, what you want, and then that can give you a hint what to change and what to change it to. But again, it's not just always do this for step 1, always do this for step 2. So, but just a tool in our toolbox. Okay, a different algebra skill that could come up is I look at question 10 and we've got 2 terms on the left. Terms are things being added or subtracted, and then one big term on the right. So I'd really like somehow to combine these together into one term. And so the way we add fractions is with common denominator. So This is what we currently have on the left. This is what we currently have on the right. And again, I'm just thinking if I add those together, I get it to one term like the right side. So maybe that's an improvement. But to add fractions, you need a common denominator. So this guy's got a cosine, this guy's got a sine. So this guy also needs a sine. You can't multiply his denominator by sine without multiplying his numerator by sine. That way you're essentially multiplying by 1 and not changing the size. And then for these to have a common denominator, this guy needs a cosine. And you can't multiply the bottom by cosine without multiplying the top by cosine. And we end up with sine times sine, which is sine squared, plus cosine times cosine, which is cosine squared, all over cosine A, sine A. Now, if that didn't seem like that helped, I might erase these steps and try a different approach. Especially if I saw a different approach jumping out at me. But I think we're on a good track, because what does sine squared plus cosine squared always equal to? 1. And we could say 1 over sine gives us the cosecant we wanted, and 1 over cosine gives us the secant we wanted. Now, if you're used to just being able to see a math question and say, okay, I know I'm going to do this, this, and this, and I get to the answer, then this can be frustrating, because you can't look at that question and say, well, I'm going to add those fractions, and then I'm going to get a Pythagorean identity, and then I've got a couple reciprocal identities. Like, you can't, it's hard to visualize the whole question from the beginning. You got to just start with something, try to plug in trig identities, and if you can make the two sides the same, then you are finished, even if it's in a different approach than me or your neighbor. But some of the more advanced algebra topics we see here is thinking about what you have and what you want and adding fractions together. Okay, another good tip is using fractions, splitting apart your fractions. You can't split apart denominators, but you can split apart numerators. So you can make this secant squared over secant squared, as long as you make it minus 1 over secant squared. You can put both of these numerator terms over the denominator. Again, this isn't the only way, I just think it's the easiest way. Then anything divided by itself is 1. This is a reciprocal identity. That would be cosine squared. And now it's looking familiar. To me, this looks like the first Pythagorean identity. But if I have this written out at the top of my page, I can be sure before I move on. 1 minus cosine squared would be equal to sine squared. Now, just a heads up, if you do this, if you don't write that last step on the quiz, then you're going to lose some points because it looks like you're stuck. It looks like you don't realize this is sine squared. You need the last thing to be equal to the left side needs to be the right side for your last step. Stopping one step before might seem obvious to you, but this is, again, these are not true-false questions. These are you showing us, putting down the work, showing us that they're true. Okay, and then let's try that one more time. So I want to kind of show you some paths and some tips here to try to avoid. Well, the last question we looked at just said we split apart our fraction, and that worked out great. So let's try that again. Put tangent over tangent, and then put cotangent over cotangent. It's like you're unadding those fractions. You're used to going the opposite direction. Notice these angles don't matter as long as they're consistent. Angle A, angle B, theta, whatever. I think most people are going to change this to 1. Anything divided by itself is 1. This is the part that I'm concerned about. So what I think some of you will do, we're going to go down the long path first, is you're going to say, well, I don't know what to do with this. And he said, as a last resort, change everything into sines and cosines. So maybe instead of saying cotangent, we could say cosine over sine. And then I've got divided by. Tangent is sine over cosine. That's me changing everything into sines and cosines. And then the way you divide fractions is to change it to multiplying by the reciprocal. Keep, change, and flip. You get cosine squared over sine squared. Which is a quotient identity that is cotangent squared. And again, if you have all three Pythagorean identities written at the top of your page, you just do it one time carefully. You can look up there and see that 1 plus cotangent squared is cosecant squared. So instead of saying 1 plus cotangent squared, I'm allowed to just say that's cosecant squared without explaining why. So that works, but it's also kind of a pain there. That's a lot of steps. But in theory, changing everything in the sines and cosines should work. I want you to, on the side here, because I want you to kind of learn from my mistake here, I want you to be as efficient as possible, just not just for your sanity, but mathematically we always aim for most consistent. Right here, we could have simplified a lot of this if we had taken a little smarter approach. Cotangent divided by tangent is the same thing as cotangent times what? Okay. I think that's true. But just like these fractions, instead of dividing by something, it's the same as multiplying by the reciprocal. So instead of dividing by something, I could have multiplied by the reciprocal of tangent. And that would have been a whole lot faster way to show that all of this that's highlighted eventually becomes cotangent. So I have no preference. As long as you can do it, I'm fine to give you full points. But again, it's a lot easier if you are paying attention and just saying dividing by tangent is the same as multiplying by cotangent, and you're skipping a bunch of fraction work there. Okay, so before we slide over, again, we need to learn and put a few tools in our toolbox here because we're going to apply some of these on some other questions. So we saw plugging in identities is going to be a part of every one of these questions. Sometimes reciprocal, quotient identity, maybe change everything into sines and cosines, some algebra skill like FOIL, some more identities, FOIL. Sometimes we need to think about what we have versus what we want to know what to change. Sometimes we need to add fractions by getting a common denominator. Sometimes we can split apart our fraction, never split apart a denominator, just a numerator. Did the same thing there. And again, if you hit a wall, changing everything into sines and cosines usually can get you to the right way. But if you just do that as an automatic, a lot of times you're going to do a lot more work than you have to do. Sometimes if you're paying attention, you can take a quicker path. Okay, so leave that one out as a resource, and let's jump over to this one. And these questions, unlike the other handout, I kind of made them as easy as possible and then slowly worked up the difficulty. On this worksheet, they're kind of random. Question 3 might be easier than question 2. Question 9 might be easier than question 8. But I need you guys to try and put some thought into some of these before we just say what they are. So I'm going to pick out some of the easier ones first. So try question 1 and see what you would do. And again, the very worst thing that you can do is just sit there and look at it. Anything that you can think to change, try changing it and see if it helps. Worst case is you erase it and start over. I'm just going to give just a minute or two here. Until you're forced to think about what to do, it's not going to get easier. But I promise it will get easier with practice. Okay, I feel like you could start question 1 the same way we started 1 on the other worksheet. Jude, what did you try?
I'm not sure.
Okay. Somebody else have a suggestion on how to start this maybe?
Split them up. Or that would be like, you know.
Okay, we could split them up. We could put 1 over cosine, as long as you put cosine over cosine. Remember, splitting apart our fraction worked on a few questions on the other worksheet. So, I'm not saying it's going to work most of the time, but when you don't know what else to do, that's got to be something that registers in your head. Okay, obviously cosine divided by cosine is 1, which is a good sign. I needed a plus 1. And then what is 1 over cosine equal to? Okay, and that's what we wanted. We needed a secant. Okay, so did anybody think of splitting apart the fraction besides Luke? A couple? Okay, so the next one that you get completely stuck on, consider splitting apart your fraction. Okay, we're not going to do these completely in order because, again, we're going to avoid some of the harder ones till later. But take just a minute or two. Think about question 2. How could you start it? What does it look like? See how far you can get in just a minute or two. Okay, so question 2, Ryder, what did you start with?
I'll start with split.
Okay.
Getting cosine squared theta over cosine squared theta, which is 1.
Okay, I can't do all that in my head that quick. So you split apart the fraction. So if it worked in question 1, it might work in question 2. That's exactly the type of thing you'll need to pick up on. That's how it gets easier. Okay, what did this come out to be?
1
Okay, and this,
cosine squared theta.
close. It's not cosine squared, it's
Secant.
sine squared. If 1 over cosecant is sine, then 1 over cosecant squared would be sine squared. And then you're starting to see this one show up a lot. Doesn't that look like the first Pythagorean identity? You have this written at the top of your page. It's pretty easy to visualize. 1 minus sine squared is cosine squared. Once again, you don't have to prove that. You just have to have that identity memorized well enough that you can recognize it and make that substitution. Okay, is anyone able to get that one before we went over it? A few more? Okay, good. Let's see. Yeah, let's go ahead and try 3. There's one trap I'm afraid you'll fall into, but try to see what you would do. And again, just a couple minutes. After a couple minutes, if you're not sure what to try, then there's not much you can do. So. Okay, so the thing that I was afraid you might fall into is if you tried to split this one up too, it doesn't work. You can't split apart fractions from the denominator. You can only split apart numerators. Let's see, if I try to make an example here like this. If you think that you can split these up with the denominator, you're saying that you should be able to put, well, the real answer here would be 3 over negative 2. That's the real answer. But if you think you can split these up, you think you can put 3 over 1, which would be 3, and then 3 over negative 3, which would be 1, and so you think the answer is 2. Not the same thing. That's not how fractions work. You can split apart numerators, but not denominators. So hopefully you didn't fall into that trap, but if you notice the denominator was the first Pythagorean identity, 1 minus sine squared is cosine squared. So you had to try that. You had to write it down before you could hope to see the next step. But then I think if you did that, you're more likely to say, okay, that must be tangent squared. And if you have your 3 Pythagorean identities written at the top of your page, because you just wrote them out carefully once, it's not a bad idea to make yourself write them down multiple times, though, to help you memorize them if you don't think you have them memorized already. But one of them should say tangent is the same thing as secant squared minus 1. So in place of tangent squared, you can plug in secant squared minus 1. That is a fair substitution that you don't have to prove. You just have to recognize it. So I kind of tried to lead you in to see if you would fall for that fraction trap, but don't split apart denominators. Only numerators. Bottom was a Pythagorean identity, so try plugging that in. And again, if you guys don't have those memorized, if you did not memorize those very well for the quiz today, you still need to do that. If you don't know those, you can't hope or expect yourself to recognize to make that first substitution, to change the 1 minus sine squared into cosine squared.
Where does it say that on the Pythagorean identities?
In the middle of the page, the 3 that we wrote out.
Yeah, that's.
Right here. That's the one I wrote down. Tangent squared plus 1 equals secant squared. So that means tangent squared is equal to secant squared minus 1. Okay, let's try a couple now. Let me give you a set of a few of them, and I'll give you a bigger chunk of time. Why don't you try the other questions on the front page? 4, 5, 6, and 7. So everything except for 8. If I remember right, 8's the hardest one. So do what you can with 4. See where, if you get stuck, then try the same thing with 5. Do what you can until you see where you get stuck. That's not a basic, since we don't memorize that as a basic identity, you still need to show me why that's true. It is true, but you need to do something to
So
show.
would that be correct? I just need to like show more.
Yeah, you need to show me how this becomes this, but then yes.
Okay.
And feel free to jump around here. When you get stuck on one, just move on to another one. Come back to it. the same thing as 1 over 5? You can't. Or it's not enough. You gotta keep doing it or do something different. So it's gonna give you several more minutes, but I'm gonna start to come around just to kind of see which ones are giving you the most issues, which ones are look like most people are getting. It's close. Not quite though. That's why it's hard one. I guess if you got the others down, you could go ahead and try 8, but again, 8 is probably the hardest one on the whole worksheet, so. Okay, I'm going to go over those questions on the front page, but again, in theory, you should kind of know which ones you need to pay attention to. In question 4, if you're not just making up some math, you're not just working out fractions in a way they don't really work out, you're not plugging in some identity that just is convenient but not always true. If you got the left side to look like the right side, then you're good and you can work on another question. I will also suggest 4 through 7, any of these that you got stuck on, You should probably circle these questions and force yourself to go back and practice them again later. So, all right, when I look at question 4, what I'd probably start with is trying to split apart my fraction. We've seen that that works often, so I will see what path that takes me along. This becomes 1, which is good because I know there's supposed to be a -1. Now, this part, I guess you guys do need to check, even if you think you got the right answer here. You can tell that this stuff is supposed to come out to be this stuff because the -1 and the -1 are where they're supposed to be. You can't just say this equals cotangent, though. The reason why you can't just say this equals cotangent is because this is not a basic trig identity. This is not one we told you that you had to memorize, so you don't get to use it as a tool that way. So if you're not sure how else to make this look like cotangent and nothing else works, try writing everything in terms of sines and cosines. So instead of calling this cosecant, call him 1 over sine divided by, instead of calling this secant, call him 1 over cosine divide these fractions by keep, change, flip. Multiply your fractions. And then finally, it does match up with one of the identities. It's one of the quotient identities. So, circle that question if you got stuck on it. If you think you did it a different way, again, that could be perfectly fine. I think this is probably the most efficient way on this one, though. Maybe not. There could be something a little bit better. But if you have a different way and you're not confident if you did it right, just ask me to look at it here in a few minutes. But anything y'all want to ask about 4 while it's still up?
Why can't you just like say that cosecant and secant is cotangent?
Why can't we just say all of this is cotangent minus 1? It's true. Because we don't memorize that this equals this, but we also don't memorize that this is cotangent. So the only reason you know it's cotangent is because you're looking at this side. But you have to, your job is not to figure out if it's true or not. We know it's true from the beginning. It's your job to show that this is the same stuff. So that's why you have to follow through. The only thing you don't have to prove are the ones we asked you to memorize. Okay, others about 4? Okay, then number 5. Now, even though I said you really should stick to one side, sometimes it's not a bad idea to kind of think about what the other side might simplify to. Like I look at this and I'm thinking of the first Pythagorean identity, and I know that's going to come out to be sine squared. Don't actually change it to sine squared, but I know if I can make this stuff look like sine squared, then it's going to be equal to that. So I don't see FOIL, I don't see fractions to add, I don't see fractions I can split up. But if nothing else happens, again, I don't expect you to do it in the first 5 seconds, but at some point you'll have to say, let me change everything into sines and cosines. This is already in terms of sines, this is already in terms of cosines, and this could be rewritten as 1 over cosine. Again, I do that as a last resort, but if you have a question like this, if you just didn't even know how to start it, with that much time I gave you, then you should have tried this at some point. Then these cancel, and then because of the first Pythagorean identity, sine squared is 1 minus cosine squared. That's one we memorized, so I don't have to show why this is true. I just have to recognize it well enough to make that substitution. And do not do this on your quiz. I say this every year, and then some people still do it. If you stop here, it looks like you got stuck and that you don't know this is 1 minus cosine squared. You need to write that in so that I know that you know sine squared is 1 minus cosine squared.
You put sine squared equals sine squared, or does it have to be the similar side equals the similar side?
In theory, yes, you can change this to sine squared, and then your last step could say sine squared equals sine squared. The only reason why I don't like you to go down that path, even though mathematically it's okay, is because, again, the very first thing I said is if you add, subtract, multiply, or divide both sides by something, it's like you're solving an equation, and that's not allowed in these. That's automatically wrong from the get-go. And so if you just force yourself to leave one side alone, you're less likely to accidentally do that. That's the reason why I would advise not to do that. But yes, in theory, you could simplify this sum, you could simplify this sum, and as long as you're not adding, subtracting, multiplying, or dividing both sides, if you make the left side look like the right side, then it would be correct.
Would you count us off? Or?
No, I wouldn't count you off. But again, I think just it's a bad habit, though. I think you might land in a different trap. So, okay, I'm sorry. Was there other questions about this one? Okay, then if you needed help with number 6, go ahead and follow along here. Now again, you could be starting this in a completely different way, which might be okay. But when I look at this, I probably would just change this. I don't see any algebra that jumps out at me. So I'm going to change cotangent into cosine over sine. Oh, this is definitely one of the harder ones. Only because nothing else is obvious to me. Then I guess I could multiply these two and get cosine squared over sine. And then very likely you're going to have to slow down and really dig deeper here. Think about what else to do. So, again, not instantly. But one thing we saw on the other handout, the easier questions, was if you've got 2 terms over here, but only 1 term over here, if you could force these 2 together somehow into 1 term, that's probably an improvement. So, to force these together, the only way you can add fractions is with a common denominator. So between 1 and sine would be sine. But you can't just multiply the denominator by sine without multiplying the numerator by sine. And the point of getting a common denominator is then you can push them together as one big fraction. Then the numerator becomes the first Pythagorean identity. And then now the left side is 1 over sine, which matches the right side. But you might need to highlight this. 2 terms to 1 term, common denominator to add those together. Hello? Yeah. Okay, thanks. Ryan, you're checked out. So again, if you didn't finish that one, circle it, add to your notes there, but again, try it again later. See if that registers the next time you think about it. Is there any other specifics you'd like to ask about number 6? Okay, and then for number 7 can be, again, they vary in difficulty. Some of them are going to take 8 steps. Number 7, I think you could do in 2 steps. Instead of saying this, what is all this equal to? Good. So 1 over secant is cosine, 1 over secant squared is cosine, sine squared, cosine squared, excuse me. So even if you don't know if that's going to help, it's true, so you can write it down, or erase it if you need to. But then it looks like the first Pythagorean identity. So you have this at the top of your page. You can glance up there and visualize 1 minus cosine squared is the same as sine squared. So you can make that substitution. Okay, other questions about number 7? Okay. Go ahead and flip it over then and try a couple questions on the back. With our last few minutes, I will let you know what you need to do and where you need to be by Friday.
Guess I'll see y'all on Friday. This is an A week again.
I thought it was a B week.
I thought we had an A week last week.
But we didn't have school on Monday.
Oh. So we're just like catching up for one day.
Yeah, we try to make it to where you at least see all of your classes twice a week. So if it was a B week again, you'd only see your 8A classes once. But I will double check it to be sure. Yes, it is an 8A. So try a few questions on the back until we get closer to go time. Also, our daily game today, the top one's kind of a trick proof. If you work that like you're doing the questions on the worksheet, then you might understand the joke to that. Again, doesn't matter what question you do on the back, just try to get one or two more done. So you can even try to pick out one that looks easiest, or the couple that look the easiest. They don't necessarily have to be number 9.
So you can like just cancel it.
Multiply what?
Just say multiply C. Just cross them both out for
You can't cancel out terms anyway. Things that are being added or subtracted.
You said you can't split a fraction from by its denominator like at all.
Only its numerator. So here's what it looks like when you split apart a numerator. It's made easy numbers. You split apart the numerator, you can simplify it and it gives you the same thing as if you don't. But if I switch that, oops. The real answer to this would be 1. But if you try to split it up this way, you're going to think it's this plus this, which is like 5 1/3, completely different. Let's go on to another one. You don't have to stay separate. We're going to go over more of these next class, so don't give up on a question instantly, but also don't sit there and stare at the same one for 10 minutes.
have to say where this came from, but you should have one step that shows these two become one. So just have your next line be 1 plus cotangent here. Oh, okay, so you're writing it, we do more of like a vertical format, like here's the step, here's the step, here's the step. If you're saying, I kind of follow what you're doing now, but I think that's kind of harder one. We've got just a couple minutes here, so finish up your thought on the question you're on. And your homework down there is I need you to go back and finish up the bookwork from last class. So you don't have to do any of this worksheet for homework. We're going to spend more time on it together next class. If you have time to try some of them, it's certainly beneficial. But last class, I know a few of you even finished that book assignment, but most people did not. So however much you have left, please do that. Any question you get stuck on, remember I have them all worked out on my website as individual videos, so that should help you get unstuck. And I don't have a due date on those yet, but I did make a place for you to turn in your 4.3 notes and your 4.3 book assignment when it's finished in the Google Classroom. So if you have those and you want to get that part over with, then but finish that up. Make sure you know that the book assignment should be finished coming to class on Friday. The worksheet does not have to be any more completed at all. And then we'll pick up